Good afternoon. Today we're going to talk about trenching and excavation safety. Good dirt. First thing we're going to do is just shake up this soil sample that we have, and we'll talk about that a little bit later. Some of our objectives today, to go over what soil mechanics, how to properly classify soils, the protective systems used for when you're doing trenching and excavation work, and some of the other specific requirements related to the excavation standard. Unfortunately, trenching fatalities are trending upward again. During the last 5 years, there was about 120 fatalities, and 71% of those during the last 3 years. So why do people keep getting hurt and killed in trenches? Well, because of these three things right here. You're not doing a soil analysis, there's a lack of a protective system, or there's a lack of a competent person. OSHA defines a competent person as one who's capable of recognizing existing and predictable hazards related to excavation work, and one who can classify soils properly and protective systems and knows the other requirements of the standard. So what's an excavation? Excavation is any man-made cut, cavity, trench, or depression in the earth's surface. You go out in your backyard and you get a shovel and you dig a hole, guess what? You've just created an excavation. A trench is a narrow excavation. Generally the depth is greater than the width, but the width is not greater than 15 feet. If the width is greater than 15 feet, then that trench becomes an excavation. So what's soil? Soil is comprised of several different things. It can be organic matter, it can be clay, silt, gravel, sands. All of those accumulated together will make up what type of soil you have. The soil strength is dependent upon what type of soil there is, whether it's an A, B, or C soil, how much moisture is in the soil, how cohesive the soil is, how good that it sticks together. And it's also dependent upon whether that soil has been previously disturbed. OSHA has classified soils as essentially really three different types, but they include stable rock. But we'll talk about these a little bit more. Type A soil is more of a clay. The particle size of that soil is very small, where you can see in the picture on the right-hand side of the screen there that those soils, the particles are very small, which they stick together better. A type B soil is the middle. It consists of a silt. Your particle size is a little bit bigger. And of course, type C is your sandy soils, where the particle size of that soil is even larger yet. Stable rock. Stable rock is a natural solid mineral that can be excavated and the sides remain vertical. Now, depending upon who you talk to, some geologists will say once you start excavating rock that it is no longer stable. But OSHA does recognize that there is such a thing as stable rock. And when you cut into rock, that those sides remain vertical. A type A soil has an unconfined compressive strength of 1.5 tons per square foot or greater. It's going to consist of clays, your clay loams and cemented soils. We'll talk about the unconfined compressive strength just a little bit later. But no soil is going to be a type A soil if you have fissures in it, which are cracks, meaning that there's cracks in the earth's surface, or as you excavate down, you create cracks. That no soil is type A if it's subject to vibration. So if you have equipment running around your excavation and there's vibration, it can't be a type A soil. It could be classified as a type B or C. If it's previously disturbed, it cannot be a type A soil. A type B soil, that's one that has an unconfined compressive strength of 0.5 tons per square foot, but less than 1.5 tons per square foot. It's going to consist of your loams, where we talked about that particle size. It's a little bit larger than the clay particle size, but it's a little bit smaller than your sands, your rocks. It's going to consist of, like I said, your loams, maybe some sand mixed in it, but it might be a type B soil, might be a type A soil that has those properties of a type A soil, but it's subject to vibration or you have some fissures in it. And some of the previously disturbed soils can be a type B soil, depending upon how well that soil was compacted. A type C soil has an unconfined compressive strength of 0.5 tons per square foot or less. It's going to be your sands, your gravels, or a sandy loam, a little bit of dirt mixed in with that sand. It can be a soil that you have water freely seeping from, or it's a soil that's submerged. Most of 99% of the time, most of your soils that have been previously disturbed are going to be a type C soil. Soils, the OSHA standard says that soils have to be classified by a competent person, and they have to do at least one visual and one manual test to classify that soil. Some of your acceptable visual tests, that's just looking at the soil. As you're excavating, looking, you know, is it dark? Does it look real hard? Does it look sandy? Is it rolling? Those are acceptable visual tests. You're looking at them and trying to estimate that particle size of that soil. Do we have water seeping? Because we said once we start digging and water is freely seeping into that trench, that it has to be classified as a type C soil. Is there vibration around? All of those things are just visual tests that you're doing. Some of the acceptable manual tests that you can do, we'll talk a little bit more about these, but you have the plasticity test, a ribbon and thread test, dry ribbon test, dry strength test, thumb penetration test. You can use a pocket penetrometer. You can use a hand-operated Torr vane shear vane. Thumb penetration test, you're just grabbing a clump of soil. You're kind of molding it a little bit. You're trying to push your thumb in it. If your thumb really doesn't want to go into it, it's probably a type A soil. If your thumb just goes to your thumbnail, it's going to be a type B soil. And if your thumb penetrates the full length of the thumb, it's going to be a type C. It's probably going to crumble on you before you get your thumb in it. A ribbon test, you're just taking some of that soil, mixing a little bit of water. You're rolling that soil out into a ribbon. Then you're taking that and you're squeezing it between your forefinger and your thumb. You're trying to let this down here get long. Pass it through the thumb as you roll it out, as you squeeze it out. If you have a long ribbon, usually between 6 and 8 inches, without it breaking off, it's going to be a type A soil. If it breaks off before this, it's probably going to be a type C, or I'm sorry, a type B. A type C soil is not going to be able to do any of this right here. So you can use the field sedimentation test. That's kind of what we did here. You take some soil, throw it in a jar, add some water to it, shake it up, put it down, twist it. As you can see here in the picture, this here has a lot of sand in it. All you're doing is seeing your sands are going to be heavier. They're going to go to the bottom of your jar. Your clay particles, so they're real light, they're going to come up here, okay? So you're actually just measuring how much you have in there. You can see in the one that we did, looks like there's maybe, I don't see any really type A type soils in here. There you have maybe a B and there you have C. It looks like you have more sand than anything because those particle size went to the bottom, so I would classify this here as a type C soil. Very easy test, very easy test. You can use the shear vane or the Torr vane test. All that is, it's measuring the soil's shear strength. What that is, it's the maximum stress that soil can offer against failure and how easily that soil will shear off. You can use the pocket penetrometer test. The OSHA regulations talk about this here. It's just a little thing that measures unconfined compressive strength. What you'll do is you'll just get a little soil sample and you'll push that pocket penetrometer into that little soil sample till you get to that red line. Once it goes all the way to that red line, you're reading the bottom of this scale, and as you can see, it's marked 1.5, and above 0.5. We talked about that type A is anything greater than 1.5, type B is 0.5 to 1.5, and a type C is a 0.5, or less than 0.5, I'm sorry. Soil can weigh, a cubic yard of soil can weigh nearly 1.5 tons. And so, when I was in compliance work, the last few fatalities that I had to investigate, the person wasn't buried. It was just the soil came in and compressed on his chest, and he couldn't breathe no longer. He actually suffocated. I mean, when you have a 1.5 tons of weight on your chest, it's literally crushing you to death. But each foot of depth down that you go in the excavation or the trench, it creates more side pressure. And once the pressure exceeds the ability of the soil to support itself, you're going to have a cave-in. And that's what a cave-in is. It's the weight of that soil causes it to gravitate downward, and that pressure pushes the soil inward at the bottom of that trench. Normally what will happen, the bottom third of that trench starts to slough off, you have no support, and the entire trench will cave in. You know, I mentioned a fissure, a crack. That's a crack. That's an imminent danger situation right here. What the OSHA standard says is that employees have to be protected from cave-ins unless it's in stable rock. Stable rock, those vertical sides are going to stay intact, or less than 5 feet when there's no indication of a potential cave-in. So, you know, yeah, we know that we have to have some type of protection system greater than 5 feet, but if it's 3 feet and the trench is caving in, we still have to have a protective system. Some of the different types of protective systems, we'll talk about them. You have sloping and benching. You have support systems, shields, trench shields, in anything, or you can have a registered professional engineer design your protective system. Anything greater than a 20-foot depth, 20 feet or over, has to be designed by a licensed professional engineer. Sloping and benching. You can slope everything at a type C. That's your first option right here. Type C is 1.5 horizontal to 1 vertical, meaning that for every foot you go down, you have to slope it back 1.5 feet. If you slope everything that's all you have to do. You don't even have to do a soil classification if you slope everything at 34 degrees. You can use appendices A and B. Those are diagrams we're going to discuss in the next slide. You can use other tabulated data, maybe from soil, or a registered professional engineer can design your system. This is just a table that's in the OSHA standards, and it shows you right there. Type A soil. So we have to come 3/4 back for every foot we go down. That equals 53 degrees. For a type B soil, for every foot we go down, we have to come 1 foot back, 45 degrees. And we already talked about type C soil. Sometimes I'll ask a person, hey, you're 8 foot deep. How wide do you have to be at the top of your trench? They'll say 8 foot, that's 1 to 1. No, that means for every foot we go down, 1 foot on this side, 1 foot on the other side. So if we're 8 feet deep, the top of our excavation would have to be 16 feet wide. These are diagrams taken from appendices A in the standard, and it just shows you what your slope would look like if you had a type A, type B, or type C soil. Support systems. Another thing we can do is we can use a trench shield, or we can use aluminum, wood, timber shoring. Those are contained in appendices A, C, and D of the OSHA standards. You can use, for those systems, you can use what the manufacturer says to use, how to erect them, what they're capable of supporting. Or we can use a design also that's done by a registered professional engineer. This is taken directly from that appendices B in the standard. You can see here's a whaler, here's an upright, there's a cross member. These tables right here, depending upon the classification of soil, will tell you what size lumber to use, the spacing for your uprights, the spacing for your cross members, and the spacing of your whalers from that chart. That just says the same thing right here. The table has the minimum sizes of the timber members for a particular type of soil. One thing to note, that all those timbers have to be of a species of Douglas fir or oak. You can use hydraulic shoring. That's contained in Appendix D of the standard. Most of the time, people won't refer to the OSHA standard on this. They will refer to what the manufacturer says, because it's going to tell you, okay, hey, you know, we have a type C soil. These have to be a certain size, and they have to be spaced so many feet apart. We can use trench boxes, otherwise known as shields. Shields don't prevent a cave-in. They're just going to protect when that wall collapses. Once again, they're rated for different classification of soils. That tabulated data for that shield would have to be on site so that you know what it's rated for in those different classification of soils. There it shows an example of that sheet. You can see type A, this particular shield and shield number, we can use it at 49 feet. Now that shield's not going to be 49 feet. That's, if you stack them. But we can use that particular shield 49 feet deep in a type A soil. As you can see, it really goes down when we get to a type C soil. We can only use it to 16 feet deep. But that data, that will come with that shield, and it has to be on the job site so that you know. If shield systems have to be free from defects that would impair their function, when they're damaged, the competent person has to make the determination whether it's going to affect the capacity of that shield. If they don't feel comfortable doing that, they're going to have to go to the manufacturer, and they're going to have to look at it, or you can have a registered professional engineer look at it. You can't have people inside the shield when they're being installed or being removed. They can be inside the shield when that shield is being moved horizontally along the length of that trench. These pictures show just a couple, talked about damage. This cross member here, what you can tell that it's bent, but so that competent person is going to have to be the one to make this determination on whether that shield is still good or not. Maybe they should call the manufacturer and say, hey, run a string line here. I got 2 inches of deflection in that cross member. Can I still use it for a type A soil? They may say yes, they may say no, or type C soil. What if you had a little puncture in your sidewall? I would say, depending upon where that puncture is, if it's going to affect the capacity of that shield or not. This bottom picture, I know one of the last excavations that I did, consultation work, they had a trench shield down in there, and it was close to the river. That's essentially what it looked like. There was so much fluid pressure that shield wasn't rated for all that fluid pressure, and the sides were bowing in, just like in that picture right there. You can't excavate more than 2 feet below the bottom of the shield. Looks like, imminent danger situation there. You have people down below the shield. If that caves in, they're just going to have the entire weight of that shield come down on them. Shield, you want your sidewalls of your shield right next to the sidewalls of your excavation or trench. This isn't going to do any good at all. If this caves in, all it's going to do is move that over there, which could, if there's a pipe down in here, inside the shield, employees are down in there, you could have that employee crushed by the side of that shield. Shield systems, they always have to extend 18 inches above the total height of that vertical side. So, meaning that, just like this picture here, we're coming up and we're using a sloping system along with that trench shield. We want to make sure that that's 18 inches above. The reason for that is going to help protect anything that might roll down in there. There's an OSHA interpretation on that if we have a vertical side right here, there is no standard that requires that trench box to come up 18 inches. Is it best safety practice? Yes, it is. But that requirement's not there. That requirement's only there is if you use that trench shield along with a sloping system. Wanted to mention house foundations because house foundations, 652 protective systems does not apply to house foundations under certain conditions. These are the conditions: that house foundation is less than 7.5 feet in depth, or there's bench for at least 2 feet horizontally for every 5 feet or less of vertical height. And the minimum horizontal width at the bottom of the excavation is less than 2 feet. There's no tension cracks, no surface water coming in. There's no heavy equipment operating in the area. You have the minimum number of crew down in that excavation, and the work is planned out and carried out in a manner to minimize time the employees are in the excavation. But that's only for house foundation. If you're doing putting in a sewer line, a water line, or anything like that related to that house foundation, that's not exempt from the protective system standards. So you're still going to have to use a protective systems 5 feet, 4 feet or less if you have cave-in problems. Some of the other specific requirements related to trenching and excavation, all surface encumbrances, they have to be supported. Here you see a picture, you have a utility pole, and yeah, they're excavating right next to it. All the standard's saying is you want to support that. Always call 811. Seems like a no-brainer, but no. Always want to locate any underground utilities prior to starting an excavation. Anytime you have a trench or an excavation that's more than 4 foot in depth, you got to have some way to get in and out. So that could be a ladder, that could be maybe a built-in stairway, or it could be a ramp. Just have to have a means of egress. You don't want to be down inside an excavation when you're moving materials in. Right here, you see, this person's down in the excavation. Excavation really don't look that good, but he's receiving a pipe. As long as that pipe's not being swung over his head, he's probably fine, because you want to receive that pipe before you put it into the next joint. Mobile equipment. If you have mobile equipment operating next to a trench or an excavation, you want to put some stop logs, some barricades or something, so you don't have this situation right here where you have a vehicle rolling over into that excavation. Hazardous atmospheres. We want to test the atmosphere. The standard kind of says, when there's a possibility of a hazardous atmosphere, and they say such as near a sewer or landfill or maybe a storage area where there was hazardous substances. But, anytime we have maybe water removal equipment down there, we want to test it. If we're welding, we're putting in a pipeline, we're doing any type of welding work in that trench or excavation, because we could be creating a hazardous atmosphere using that type of equipment. So we would want to test the atmosphere. You don't want to work in a trench or an excavation where water is accumulating. So, we want to control that water. It could be by a pump, it could be by diverting the water some way, but you have to have a competent person when we're using a pump or that water is diverted to monitor that situation. Stability of adjacent structures. We don't want to undermine any sidewalks or pavement where they could collapse. I don't think this tuba tin over here supporting the corner of this house is going to do the trick. Looks like they've had, maybe that's the reason why they're doing it, because we've had some separation of that foundation. But we don't want to undermine that. We want to have a qualified, competent person look at that and determine what's the best way to support that. We always want to keep our material 2 feet back from the edge of the excavation. That's going to help that material roll from rolling down in here. Here you see a pretty big rock. This is not protected at all. If this rock comes down, hits this individual down here, it's just going to break his back or his neck. So we want to keep that excavated material 2 feet back from the edge. The standard requires that a competent person do an inspection of that trench or excavation every day and throughout the day. Those conditions can change immediately. Your soil classification can change as you're continuing on digging. So you may have to make 2 or 3 soil classifications or more throughout your excavation. But that's what it states. Daily before the start of work, as conditions change, when it's raining, when you observe cracks or fissures, you have to look at that protective system all the time. If you find conditions that could change or that have changed, maybe soil conditions from a B to a C, we have to remove those employees from that excavations till we fix it. Lastly, the standards, just a general training standard. It states that the employer has to train or instruct their employees in the recognition and avoidance of unsafe conditions and the regulations which are applicable to their work. All that's stating is that if you're going to be doing excavation work, we want to train all of our employees to recognize hazards associated with trenches and excavations so that they can recognize that hazard, take it to the competent person, get out of the excavation, and hopefully that will prevent a fatality. Hopefully you learned a little bit today about soil mechanics, what's involved in classifying those type soils in accordance with OSHA regulations, whether it be an A, B, or C. You learn some of the different type of protective systems that are out there and some of the other general requirements of the excavation standard.